does this whole thing really matter, biblical creation? I mean, come on, this is way back in the book of Genesis. This is, millennia ago. Maybe the New Testament's good, and we know it is, but it's so controversial, all this creation stuff, the age of the earth and the flood and how it all started. What do you think? Does it matter today? What do you think my position's going to be? Yes, of course it does matter. And there's a way to kind of research this. There's a little story with this question. Now, there, way back in New Testament times, the Apostle Paul was visiting Athens, Greece. Now, that was the leading city of the day. All the big shots were there, the intellectuals, and a lot of smart people, but they didn't know much at all about the God who made everything. So Paul is walking around, and he sees all of these statues and images. They're still there in Athens. If you visit the place, it's ruins that they've restored. And they had everything there. They even had an image set up to an unknown God, just in case they had missed anybody. I mean, interesting how they did that. So I got to wondering, when Paul goes to these worldly people, how does he start? How does he tell them about his worldview, his faith? Because they just don't know beans about anything. How does he begin? And it kind of shows us there in that Acts. Let me just grab a couple verses there. Paul says, proclaim to you, there's that unknown God. The God who made the world and everything in it is the Lord of heaven and earth. I thought that's an interesting way that Paul starts. See what he does? He starts with a beginning, talking about a God that we're responsible to. What a novel idea to start at the beginning. And I think if that made sense in Paul's day, that still makes some sense today also, because once again, we're surrounded by people that know very little about the God of the universe. So it makes good sense. A starting point, creation does matter. It's kind of a foundation for the whole thing. Are we going to switch? See if I can ruin this one. Okay, thanks for your help. What a crew you guys got here. This is great. Well, kind of title this thing, Some Lessons from Space. There's so much going on in that area of science. That's all kind of fun. But once again, even before I get into this, let me mention a current interest of mine as we look at nature and creation and everything. In fact, let me bring up Indiana. Now, back there, we are surrounded by cornfields. It's flatlands, great farmland. And well, we've studied corn and just how it grows in the spring. And this picture on the left kind of shows a shoot of corn that they've pulled out of the ground. See that? And what we have found is on a sunny day, the light from the sun goes right down to the stem of the corn and goes underground and lights up the roots. If you could dig the soil out of the way, there's actually light underground. That's how solar energy, that's how the corn grows, along with the water in the ground and the nutrients. Pretty neat how that works. So there's a name for that, conducting light from one place to another, fiber optics. And that's the way our email and other signals go around these days. Fiber optics is replacing a lot of metal wires all over the country. So that's kind of neat stuff. Corn is some kind of original fiber optics. Now, I was just thinking about that area of design, and I brought some fiber optics along here. It looks like fishing line. And this stuff is, it conducts light from one place. So let me just put the mic down for a minute and kind of, let's try a little experiment to show how this works. I'm going to take this stuff and kind of spread it out, and let's see if we can get light to go from one end to the other. Let's see, could you help me? Can you just kind of hold that? You don't have to stand up or anything, but just kind of hang on. And what I've got here is one of these green laser beams. Now, you got to be careful with these things. Don't point them at the sky. You get in trouble with airplanes. But we got this, yeah, it's tangled up. It's got knots in it, but that's okay. Now, think with me, guys. If this was, let's say this was a garden hose laying in your yard. Could you shine a flashlight in one end and get the light to come out the other end? I've never tried it, but I don't think it'll work. But this is fiber optics. So let me try this. We'll just watch the end that he's holding here. Is this working? Yeah. This is better than TV, isn't it? If this thing was stretched clear across Seattle, the light would come out the other end. If this is good fiber optics. Clear across Washington, you get 100% in, total internal reflection, and out the other end it comes, fiber optics. So they're working to improve this stuff and, for communications. And what's one thing they're studying for fiber optics? to learn how to get it better? The screen? They're studying Indiana corn. So that's God's fiber optics. Thanks a lot for your help. We'll just get that out of the way. Sorry about that. I think that nature is filled with thousands of ideas like this that God put there for us to find, to come up with new products and solutions to products and answers to questions, and on it goes. It's kind of a neat area. In fact, a friend and I have put a book together about this. Actually, one of my students at Grace College, Discovery of Design, and we have 100 of those examples. You know, Velcro came from the study of nature, and so many other things as well. So that's just been a kind of a hobby of mine, looking at these ideas in nature. It's all intelligent design, really, and it's good stuff. Okay, well, that was just a little promotion there and design in nature, but we'll go on here. We're talking about astronomy, and so this goes back to day number 4, when God makes the heavens. It's my favorite day of the creation week, because that's when 99% of creation shows up, all the heavens. Here's the verse that kind of goes along with day number 4. God made 2 great lights, the greater light to rule the day. It's up above the clouds there today, the sun, and the lesser light to rule the night. Of course, the moon has no light of its own, but it's a great reflector. And then the stars also, day 4, when this all happens. And so we're thinking a little bit about astronomy this morning. By the way, these days of creation, day 1, day 2, you know, Genesis 1, what do you think those days were like? Were they really long periods of time? There are people that say that it's called the day-age theory. Other people say maybe there were gaps between those days, so God could kind of rest up between each day. You know, they're trying to fit in more time. And I read those different theories, day-age or gap theory, and it seems like we're trying to help God out. He doesn't need our help. Couldn't he make everything in a microsecond if he wanted to? Or spread it out over trillions of years and still been at it. But I believe that those days of creation were just like this week that's going by, Wednesday, Thursday, Friday, 24-hour days. Why not? Scripture mentions the evening and the morning and the first day and the second day. You know, why complicate it? In fact, here's an interesting verse that goes along with creation. In 6 days, the Lord made the heavens and the earth and then rested on the 7th day. You see a pattern there? That's where our calendar comes from, with 7 days. There's nothing in space that has a 7-day cycle. The moon doesn't do that, the planets. So why do we have a 7-day week? It goes right back to creation. I think God did this for us. The calendar is a witness to a literal supernatural creation. So there. Some cultures over the years have been a little bit embarrassed about that calendar, because it sounds kind of biblical. 7-day cycle goes back here to Genesis and Exodus. And so some countries in the past have tried to change the calendar. We don't want to have 7 days. Let's get rid of that. Let me show you a couple of these experiments that were tried. Back in France, French Revolution times, they said, let's have a 10-day week. Now really, isn't a week long enough already? I don't know what they called the other 3 days, but it was sort of a decimal type week. When they set that up, the French people were totally confused. They didn't know when to go to work, when to go to school. Society started to break down. There were riots. They quickly went back to a 7-day week. Then this experiment was tried a century ago in Russia. They thought, let's have a 5-day week. There, that's the end of 7 days, the whole biblical idea. In fact, their week went like this: Monday, Tuesday, Wednesday, Thursday, Friday, back to Monday. Tomorrow would be Monday. Anybody in favor of that? It was crazy. And the Russian people liked their weekends as much as anybody. And there were riots and they were killing each other. And, you know, society started to break down. They quickly went back to a 7-day week. It's part of our psyche. It's part of our makeup. And it's all biblical. I think that's why God set it up for us. Let's not tamper with the length of the week. You just get in trouble when that happens. So anyway, I'm taking those days as literal in every way as for us. So anyway, I'm thinking a little bit about astronomy and what's going on in space, and it's just kind of neat, all that stuff above our heads. So here's our neighborhood. You remember that, the solar system? You guys got to learn the planets and how to spell them and all that kind of stuff. And way on the far edge there, we've got Pluto. Aren't you still sticking up for Pluto? A while back, they called it a dwarf planet and kind of demoted it, but it's still out there. In fact, we really haven't heard the last word on Pluto. I mean, whatever you want to call it, it's still there. In fact, last year, 2015, for the first time, we got close to Pluto with a New Horizons probe. I mean, it's 3 billion miles out there. It took it 9 years to get there. In fact, if you had your friend on Pluto and you were calling them up, it's like 5 light hours away, as fast as light travels. So you call up and you say hello, and 5 hours later they would hear you. I mean, that's going to be quite a cost on that phone message, because just the passage of time. But anyway, it got out there, and we got the first picture of Pluto when it got out there, and that's been sent back home, however they're able to do that. So here's our 2015 picture of Pluto, never been seen before. And this was very surprising. It was thought that Pluto is just going to be a dead desert place. It's so cold and dark and nothing out there. But it seems like it's got some features. That big white area at the bottom is a snowfield, a mixture of different, both water, snow, and other kinds of ice. And it's got some canyons and volcanoes. It's kind of an exciting place. Now, there's nobody out there. It's really cold. But there it is. So this is kind of a neat picture. In fact, I'm looking at that big snowfield at the bottom. You see that? You almost see a shape there. I was looking at that and thinking, yeah, there's a Valentine on Pluto. I had to talk myself into it, but it's kind of there, a Valentine heart on Pluto. Anyway, the bottom line, what they've learned from this planet is there's just no other place like it. We've got these, 9 planets going around the sun, and actually we're finding lots of other planets going around other stars, and apparently they're all different. There's no two alike. You know, in a universe that would form by chance, just from gas or whatever, it would all be similar. It would all be like homogenized, but every planet is different, and these frustrate all these natural origin theories. Anyway, I like Pluto. It's a good friend, and we've still got lots to learn about it. This is one of the conclusions from this whole space age. As we look at Pluto or anywhere else, how do you like that? There really is no place like home. Even on a rainy day, maybe you don't like this rain, but really, does it rain on Pluto? Or on the moon? Or on Mars? Or anywhere else? This may be the only place in the universe where we get rain falling down. It's a miracle. It's all part of that hydrologic cycle that you guys study. Well, I'm just doing some basics here again in astronomy on a Friday morning. I was thinking about this moon that we have that's our nearest neighbor in the sky. This is a picture of a Moony Eclipse. You've seen one of these before, maybe. You have to have a full moon, and then once in a while it passes through the Earth's shadow, and it doesn't disappear, but it kind of gets this orange-brown color, an eclipse of the moon. It's not that unusual. It happens like once or twice a year, and I was just looking. Our next moon eclipse is February 10, 2017. Anybody got a birthday on February 10? That'd be kind of special to go along with the eclipse. Anyway, that'll be something to watch for, and you'll see that in the paper. Maybe go out and watch this moon. It lasts for several hours as it turns red, and then pops out again. These eclipses are pretty neat. You know exactly when they're going to happen. In this case, months ahead. These things follow the law. These laws of the motion of the objects in the sky, and I'm in physics, and we do have the law of gravity and the thermodynamics laws, and we just take them for granted. But it's kind of like the laws that God set up, and they keep the whole place dependable and working. This is the other kind of eclipse that can happen. Can you see this picture? It's the sun with a bite out of it. The moon is kind of moving in front of it, so it disappears a little bit. You've probably seen one of these also. This is a partial eclipse. That happens every year or so here in Washington. And if any of the sun is coming through, it still is plenty bright outside. Once in a great while, the moon completely covers the sun. Then in the middle of the day, it gets dark, and the stars come out. I've never seen one of those. They're kind of rare. But I wanted to tell you that this is kind of a neat time to be around, because here's what's going to happen next year. This is next August. Whoops, let me go back to this one a minute. You see that yellow band? This is the path of a total eclipse that's going to move right across the country. It's missing Washington. It's down there below you, so you'd have to travel south or somewhere, and zipping right across the country. First time in 100 years that this has happened. So we're living at a good time to cross the whole country. Along that yellow band, it will get dark at noon for about 3 minutes. Can you imagine what this does to birds? Because they settle down when it gets dark. They think, well, that was a short day. And so they all kind of nest in, and then 3 minutes later, bang, the sun comes back out. The poor things, but I'm sure they'll recover. So this is something to look forward to, and you'll be hearing a lot more about this since it's about 9 months away now. That band is a couple 100 miles wide. Looks like you'd have to travel south a little ways, and a total eclipse of the sun. So there, you're the first one to hear about that here, and we'll be hearing more. Kind of a neat phenomena. By the way, when this does happen, even though it's quite rare, it happens in pairs. There'll be another one of these 7 years later. So we're living at a good time to see these kind of neat celestial phenomena, as they're called. Things happening. Let me say a little bit more about this moon of ours. Looks like we got some Canadian geese flying by. Over the years, there's been lots of research, lots of effort figuring out how that moon got up there in the sky. I mean, the origin of the moon. We already read that verse, Genesis 1:16. God put it there. But in these days, we need to have scientific answers. So if you would look this up in an astronomy book, you can find out different ideas they've come up with for the origin of the moon. Let me review these with you. Now, some of us go way back to the 1960s, way back. And back then, there was this theory that was in all the books. That was before the internet, but here's what they taught us. They said, what is this picture? What do you see? A bowling pin? The idea is that long ago the Earth was spinning much more rapidly than today, and it was turning so fast that a bunch of mud kind of broke off from it and became the moon. Remember on the playground when the merry-go-round gets going too fast and you get flipped off? This is the thought that the moon was born from the Earth. Boy, that's kind of a dramatic, it'd be fun to watch that happen. The fission theory that the moon came from the Earth. Well, let me tell you, this idea went away in 1969 and just got taken out of all the books. Now, that's before your time, but what happened in 1969 from space thinking? You've heard of the people that walked on the moon? Is that true? Did we go to the moon, or is that all a hoax? Have you guys gotten into that whole conspiracy stuff? We did go to the moon. 100,000 engineers helped pull that off. I think we have some good justified pride in that whole mission. Some people are denying history. They're trying to confuse you students. They're trying to rewrite things. The moon is part of what the U.S. was able to pull off. Anyway, when they went to the moon in 1969, Neil Armstrong walked on the moon, and they brought rocks back to the Earth. And when they study them, they're just enough different. They don't look like Earth rocks. They'd be the same if this happened. So that was the end of the fission theory. Kind of a neat idea. So it got replaced in the 1970s with the capture theory. So this took over all the books. They said, here's what happened. Long ago, the moon, looking at that picture there, just drifted through space and came close to the Earth. And we reached out with our gravity and captured it. Gravity is kind of a mysterious force. It just holds us on the ground. If you jump, back down you go. We can't see it. It's a mystery, but it works. Gravity, the Elmer's glue of the universe. So the thought is we reached out and grabbed it, and it's been circling us ever since, the capture theory, but it doesn't work. If the moon would come close to the Earth, it would definitely feel our gravity, and it would go like around that outer circle, but then at about a half a turn, we would lose it. It would take off, it would gain speed like crack the whip or a stone out of a slingshot, and it would be gone. No, to keep the moon, you'd have to slow it down, put on the brakes, carefully insert it into orbit. And how do you do that with these naturalistic theories? So capture went away. That's the funny thing about science. It just keeps rewriting itself all the time. So now we're up to the 1980s, and we got the Nebula Theory. There'll be no quiz over this stuff. Nebula just means a cloud of gas or dust. It also makes a nice girl's name. It's just, there's the word, but a gas cloud. This material. And so the thought was you had these clouds in space, and they just kind of shrunk side by side and formed the Earth and the moon, and there they are, the Nebula Theory. There's another problem with this one. We can see some of these big clouds in space, and they make neat pictures, but all these clouds seem to be expanding. They're stretching out. They get bigger. They don't pull together. So I've been in this business for a while. And I've watched these origin theories, and they roll on by. Fission, capture, nebula. Let me just show you the last one here. This is the current idea. In fact, it's hung on for a little bit longer than others. See what this is? Looks like a big potato coming down. This is supposed to be an asteroid or a comet that comes down and strikes the Earth. And it hits the Earth so hard that it breaks the Earth into pieces. And some of the fragments fly up into the sky, and then they coalesce together to make the moon. And the remaining part of the Earth tumbles together. All the details have not been worked out. And this is kind of a hybrid of fission and capture, and it doesn't work either. Our computer studies of this, some of them show that there should not be any moon. Other ones show that there should be a ring or two moons. These theories, they just roll on by one after another, lasting a decade or so. And after a while, it just makes a person want to humbly suggest, maybe we can't explain the moon. You know, maybe somebody put it there because all these theories fall short. And think about this now. The moon is our nearest neighbor, and we can't figure out how it got there. I'm not sure we have any right to talk about the planets and the stars and the galaxies if we can't even get to first base with the moon. Now, one thing that I really like about this whole creation viewpoint, remember biblical creation, Paul, the book of Acts, all that? As soon as you say God was involved, then it's not by chance or accident, but there's reasons for things. So let me ask you guys here on a Friday morning, why did God put the moon in the sky? Does it do anything for you? Would you miss it if it was gone? Who cares about the moon anyway? What comes to mind here? What does the moon do for us? Got one?
Doesn't it make waves?
Waves. The tides. The tides, yeah. Again, that's that invisible gravity, but back and forth the water goes. You got one for us? Okay, it's light. It's a night light. You know, I tried that on somebody. I was giving this talk where I had a bunch of critics. So they weren't as friendly as you guys. And somebody said, moonlight, we don't need that. We got flashlights. And I thought, is that the best you can do? You know, a lot of people don't have flashlights. And all through history, of course, the moon has been very important for light. Actually, the moon does more for us than we can think of. As you're thinking about purposes of the moon, maybe even a lot of songs about romance about the moon, and that's poetry, and that's all part of it. But I started a list of just some of the things the moon does for this, and it's not a complete list, but it's a starting point. The moon does this and more. The whole creation viewpoint, that there's reasons and purpose behind it all. So I mentioned the night light, and certainly a very valuable, you know, some nights not much moon, other nights a full moon, round and round it goes. And it's so regular in its motion, I got some C words there. You can tell time by the moon. You can tell what season it is. You can tell direction. We've learned in just the last 20 years or so that the moon is why we have the seasons that we have. The moon stabilizes the Earth. Remember what a globe looks like, tilted 23.5 degrees? If you didn't have the moon, the Earth would wobble back and forth, and you might go from summer to hotter summer. You'd never know what was coming next. Thank you, Lord, for the moon. So we have seasons. We all like the seasonal change. And, there's the tides that we were thinking of. I had just room for one more word on the list there, so I put life. And by that, I'm thinking your life and mine. It depends on the moon. See if I can explain this to you. The moon causes the tides. It's a major component of the ocean currents. Huge pull, trillions of tons of force pulling on the water, whatever this gravity thing is from the moon. So back and forth the water goes, and it keeps the ocean stirred up. It keeps the ocean healthy. Now there's a lot of living things in the ocean, right? I mean, you got the fish, but there are also vegetation. There's plants. Are there plants in the ocean? Lots of it. You got the floating plants, the plankton, called them, the grass of the seas. And then you have kelp forests in the shallow areas. Now remember, plants breathe the opposite of us. They take in CO2 and they give off oxygen. Current estimates are that sea plants make over half of our oxygen in our atmosphere. So now think about this. If we've got no moon, we've got no tides, so the currents will be diminished. In fact, the ocean would go stagnant. You wouldn't want to go to the shoreline anymore. And all the fish and the plants would die. Oh, there goes the plants. There goes the air. There goes us. Our very breath depends on the moon keeping the sea healthy, keeping us healthy. Even in a world, it's fallen and we got plenty of problems in this world, you can still see how God's put this all together for our well-being. It's good stuff. And I find creation science just so refreshing, looking at the positive side of things, how God has set it up for us. I'm looking at that list and I'm thinking there's probably 10 more things we haven't discovered yet that the moon does for us as it goes on and on. It's great stuff. Hey, let me move on here. I just had some more astronomy pictures here, just general interest here, since we all kind of look at the sky now and then. The center picture there is the night sky, and it's too small to see, but I wanted to mention we have what's called the summer triangle, and it's still right above us here in Washington through part of the fall season. It's like the three brightest stars, and if it would clear off one of these days around here, then you can see them. Can you see kind of like a triangle? And I was labeling the stars, and we're able to measure the distance to stars these days. I mean, we're never going to get there during this age, but using something called parallax, we can measure distances. So there's Vega, really a bright star, 25 light years away, and 1 light year is 6 trillion miles. And there's Altair down in the corner, 16 light years away. Oh, that's closer. And look at Deneb, which is one of the brighter stars, but my goodness, 2,600 light years away. That must be a large star, much bigger than the sun, that it can be that far away and still look bright. So anyway, that's kind of something to watch for. You could be a stargazer. It's a great hobby. It doesn't cost anything, and wherever you go, you can see those stars in the sky. While I'm talking about stars, let me show you a few of these pictures. These are constellations. Now, this has all been, counterfeited with astrology and horoscopes and all that kind of stuff. But I think we need to take it back. It's for us. God made all this on day number 4. So here's some things in the sky. This thing is called the Northern Cross. And that's right above us also here in our summer and fall season. The Northern Cross, they kind of put the swan above it, but there it is. And there's also what's called the Southern Cross. I'll get to that in a minute. This picture, boy, that's a night picture showing some stars. Can you see anything in there? Like toward the bottom of the picture? I was just trying to do something familiar. What is that? It's the Big Dipper, so there it is. If God had put those lines in the sky, it would sure make it a lot easier. But there they are. Yeah, this is the Big Dipper. Those stars average about 100 light years away, and it's wonderful. We can all see that, and it is kind of shaped like a dipper. By the way, there's a couple other interesting things in this slide, just showing some things that are in your sky that you can see during your whole lifetime. There's what's called the Little Dipper. These are both in the north, and got to get away from the city lights maybe. The Little Dipper is almost as big as the Big Dipper. There they are side by side. And then this slide also has one important star in it. And some of you are into this stuff. Here, let me have an arrow that points at it. Yeah, it's the beginning of the Little Dipper. And that star must be the North Star, Polaris, the pole star. It's not the brightest, the biggest, the closest, but it's positioned right above the North Pole of the Earth, and so it's the one that doesn't move. Everything else seems to move across the sky at night because the Earth is turning since we're on this, big ball. But that's kind of like the pivot point, so it's right there every day, every night for your whole lifetime, the North Star. That's been very useful, of course, to people for finding direction. That might help you when you get lost in the big woods. Find the Big Dipper, find the North Star with those pointers, and then you can get your other directions from that. It really works. And those stars, they really haven't changed their position, I believe, since God put them there on day 4. There hasn't been that much time, and they're so far away. They might drift a little bit, but not a lot. I just had to put this picture in here. Have you ever seen a bird sitting on the corner and lost and not sure which way to go next? Now, I'm not sure owls even migrate, but I thought the picture was kind of cute. How do birds know direction when they migrate? Like the hummingbirds, they've taken off here from Seattle area and they've headed down to Florida or Mexico, and they don't do this. They don't need maps. They just seem to know where they go, and they fly thousands of miles. So they've studied these birds, and they've come to realize that birds, they follow the stars. Some of their migration takes place at night. And so they're looking at Polaris, and they know which way is north and south. I don't know how they do these experiments. That's biology. It's not my world. They work in planetariums, and they've determined that that birds follow the stars. So maybe we don't know much about the stars anymore, but birds do. It's in their DNA, these star maps. So they just don't do this. The stars are very useful to the bird world. They know what's going on. Boy, birds also, they follow the landscape on the ground, and maybe they can hear the waves off the coast. They have all these multiple ways to stay on track. We get lost. We need GPS. They've got built-in GPS. Birds are smart critters. Many animals have that kind of, mechanism for travel. Let me leave that crazy picture behind. I'm still looking at constellations. Anybody know whose flag this is? This has got to be down south here. Actually, Australia and New Zealand have similar flags. This is Aussie, this is Australia. And they're real proud of that thing called the Southern Cross. I was just going to highlight it right there on their map. And I find this interesting, that this symbol of the cross of the gospel is in the southern hemisphere. They see it down there. And we have the northern cross that I showed you a moment ago. Everybody can see it. There are these pictures in the sky if you take the time to look at it. And I think it's by God's design. Again, these things haven't changed since God put them there. And there it is if you take the time to look at them. People don't look at the stars anymore. We got all these security lights. It gets harder and harder, but it's still up there. Hey, let me just address a few basic questions with you for a little bit here. How about this one? I numbered these questions. Did it all start with a Big Bang? We've all kind of grown up with this. Now, the Big Bang theory is that long ago, the whole universe was in this little nugget. This is before we got here. And one day it became unstable and started to expand. And so it's gotten bigger and bigger over time. And as the whole thing cooled, dust started to form. And then it came together to make planets and finally people. I guess because here we are, the Big Bang theory. It makes a great story, but it's just a theory. Again, I've been around this stuff for a while, and I noticed that before the Big Bang, they had something called the steady state theory. And actually, the Big Bang is on its way out. It's going to get replaced by something else later on. It's like the moon theories. They just kind of come and go. And actually, this idea of a slow, gradual expansion of how it all began, it doesn't match up with Scripture, which is part of our textbook here at our Christian school. So here's a verse, Psalm 33:9. God spoke, and it was done. He commanded, and it stood fast. That doesn't sound like the Big Bang theory. It doesn't match up even the details. I'm just going to leave this with God and say, yep, it was supernatural. I don't know how he did it. Maybe he just spoke and bang, there it was suddenly. But none of this, uniform, slow stuff. I had put one more word on the slide here, extra credit. Can you see it at the bottom? It's actually Latin, ex nihilo. What that means is from nothing. Some of you guys are creative. You can draw a picture, you can do landscaping, you can take pictures, all that kind of thing, but we always use materials. When God creates, it's from nada, from nothing. Really, biblical creation is in God's realm alone. That's kind of what that word reminds me of. Well, again, I was just answering a few questions about this stuff just for fun. I was using this earlier, what is a light year? And I had to put Buzz Lightyear in there as well. So you heard that term, and it's just basic stuff. And I think the more we know about creation in the sky, the more we can enjoy what God made. So what is a light year? The word's kind of confusing, actually. They give it a bad name, but we're stuck with it. It's not a time, even though you have that word year. It's like a yardstick. It's a distance, right? We talk about stars being so many light years away. So it's a distance. And you need that in astronomy because the distances really are huge. And so there's the value again. Did I put enough zeros in there? Like about 12 of them? Because it's 6 trillion miles. Space must be something else to have those kind of distances, but they are really out there. So it would take a whole year, all of 2016, for light to travel that fast. Does it seem like light is instant? When you hit the switch, the light's just there? But it does take nanoseconds to travel, and those are the kind of distances we have. And by the way, I was putting in some other comparisons here, just for the record. The moon, 1.3 light seconds away. You might have noticed this if you watch the news, where the guys and gals are interviewing somebody in the U.S. and somebody over in Europe, and when they're talking back and forth, the guy or gal will just kind of stand there for a minute. Have you seen that? They're waiting for the signal to go up to a satellite and then bounce down to wherever they are, and it takes time for that. We're just kind of trapped by that time delay, the speed of light. That's as fast as it can go. And there's those Big Dipper stars averaging 100 light years away. That means that if you could go out tonight and see the Big Dipper, that light started out in 1916 and gets here in 2016. There's a time delay. Now, I want to be careful when you get into big distances, because God made a fully functioning universe, but you have that kind of time. Oh, there's the distant stars, billions of light years away. Got another question for you here, just going through some basics. What do you think about these aliens? Now, my picture might be too small, but did you see who I put in that flying saucer there? Are you guys into Veggie Tales? Well, there it is anyway. We all kind of wonder about this, and they make these movies about aliens and all this kind of thing. Great stuff. There's this common assumption that life is pretty simple, and so it must be lots of it out there. In fact, I read these articles that are written, and the thought is, if we can find a new planet, maybe not Pluto, but maybe somewhere else, and maybe that planet will have water on it. And if there's some kind of energy like sunshine, and if you let enough time go by, life will show up. There's that sort of thinking. And I want to say, I don't think so. Life is not that simple. You don't just add water to get it. As you find out in your biology class, DNA, the cells are just so complex, it just doesn't happen. That's kind of a grand assumption that it happens easily. Well, let me tell you about an interesting person here. There's this picture, Frank Drake. I had to get one equation in here. My world is physics, maybe too small to see. But since this guy is into this area, he came up with a formula to calculate how many aliens there are in space. Okay, this is called the Drake equation. So n is the number of planets with evolved life in our Milky Way. That's our galaxy, that big spiral. And so there's his formula. Little n is the number of stars in the Milky Way. We have an estimate for that. And then he's got all those little fractions. One involves how many of those stars have planets. Fraction of stars with planets, because you can't live on a star, it's too hot. You got to live on a planet. Then you hit that with another fraction, the number of those planets that have that are Earth-like, so they're solid, so you can stand on them. And his final fraction is the number of those kind of planets where life has started. He calculates it. He writes whole books on this kind of thing. Okay, now maybe you're not into these formulas here, but let me show you what he does with the numbers here. We're figuring out how many aliens there are out there. So here's what he does. The number of stars in the Milky Way, he puts in 100 billion. Okay, that's 1 followed by 11 zeros. That's probably correct. Our sun is one of them. Then he thinks maybe 1 out of 10 of those stars have a planet. You see the 0.1? That kind of knocks it down. And then the number of those planets that are like the Earth, he hits it with another 0.1. Then he gets real generous here, and he puts in a 1 for that last thing about life. And he ends up saying there must be, in our own Milky Way, 1 billion inhabited planets. How do you like that? Now, I don't know if you guys are following me, but do any of you see a problem with this? If this professor was here, could you challenge him on any of these numbers? You say, who am I to take on a professor? Anything look kind of fishy there about that? Maybe I went through too fast to see it. I heard somebody say something about that 1 on the end. That needs to be challenged. See, this is very optimistic, saying that if things are just right, there will be life. And I think that this thing is wrong, so I'm going to change this a bit here. I'm going to take his formula and I'm going to put in the numbers that are more correct. The number of Earth-like planets where life has evolved is not 1, it's 0. All of our experiments show that life is so incredibly complex, it doesn't happen on its own. And when you put a 0 in for that last term, the other numbers don't even matter. So how many worlds in our Milky Way where life has evolved? Nada, 0. In fact, we don't find any life out there. And the astronomers are saying, well, where is everybody? It looks more and more like we are special and unique, and I think we are. So anyway, back to that original question, and I think Scripture backs us up. Here's Psalm 115, the highest heavens belong to the Lord, but the earth He's given to man. It's definitely, God made the earth a special place for us. Hey, just got a few more little questions here as we're going on here. Don't want to bore you with this astronomy stuff, but it's so much fun. Is the universe expanding? Does it take you longer to get to school every day? Try that excuse. Actually, the universe is expanding, but not the Earth, not even the solar system, not even the Milky Way. It's the big picture that all the galaxies seem to be spreading out. And this is often taken as evidence for the Big Bang. But actually, I believe God made this universe large and getting larger. It's getting bigger every day. I mean, things are coasting outward. God set it up and has been just coasting ever since. And I think there's a reason for that. If this whole universe was made with galaxies just kind of parked out here and here, sitting still like static, if you just have galaxies sitting still, you know what would happen? Gravity would take over and everything would start to fall in toward the middle. You'd have the big crunch. The whole universe would become unstable. It would collapse. You need to have this kind of outward motion to make a stable universe. I think that's the way God set it up. Started large and getting larger. So there. Couple more questions here. How's our time? Yeah, we got a few minutes left. Just basic stuff. Have you seen a shooting star before? I talked to somebody the other day who said they'd never seen one. You guys need to get out and look at these things. They're not stars. Stars are too far away and too big to shoot through the sky. These are small pebbles. You could hold them in your hand usually, maybe the size of a marble. There's a lot of debris out there. And as we go around the sun, we kind of sweep up some of this stuff and it falls through our air and lights up and makes that kind of a quick breeze in the sky. And then you can make a wish and all that kind of thing. If they're larger, they might hit the ground. That's kind of unusual. Then it's a meteorite. But a shooting star is really a small object in our upper atmosphere, 50 or 60 miles high. How can we see distant stars in a young universe? This is kind of creation interest, creation research, and I'm not sure what the best answer is. I'm going to take the easy way out here on a Friday morning and just say I think God made it that way. I think He made the stars with their light thoroughly spread out, and it's still being looked at, and there's different options, but I like the idea of a mature, fully functioning creation. Couldn't Adam and Eve gone out and seen the same stars we saw? I mean, that's the way it was set up. That's the purpose of the stars, to show God's glory. Got to have another big number here, kind of almost too dark to see, but how many known stars? How many have we counted up through 2016? How many stars do we know of? This has got to be a big number, right? So nobody knows this, but we can make estimates, statistics, and when you add them all up through 2016, we got there's 22 zeros there. So that's a good sized number, 10 billion, trillion stars. Hey, what if we divided these up? One for you, one for me, one for somebody over in Germany, the whole world. The whole world, how many stars would be your fair share? You'd have to divide this by the population of the world. You'd have over 1 trillion stars. You'd be rich. Oh, be careful, they're not ours. And it's one area of, creation we haven't been able to mess up. It's just way out there, but an incredible number of stars. And I just reading in the news this week, I'm going to have to add another zero. They're saying, nope, it's 10 times bigger than that. In fact, I really think that it's much bigger than that God made a universe far larger than anybody's imagined. Hundreds of zeros, maybe an infinite universe kind of creation happened on day 4. Well, you've gone to the beach before and walked into a sand dune, take your shoes off, sand. And we've got it around the Great Lakes. I'm back on Lake Michigan where I live in the Midwest. Engineers are good at estimating numbers. In fact, you can come up with an estimate of how many grains of sand there are on all the seashores of the whole world. Around the ocean, around the lakes, around the ponds. Some places there's sand, sometimes there's not. If you do that, estimate the number of sand grains, you know what you come up with? 22 zeros, the same number. It's kind of cool. You have to tweak the numbers a little bit, but it's the same order. As many stars as there are sand grains. So anyway, it's something else as this goes on. And we're going to quit here, but just some ideas from space, just a wonderful area of astronomy and science. Hey, you guys do your best in science. You don't all become scientists. You're all going to have different interests, but boy, the more we know about space, it's for us. God made that for us to enjoy most of all. So do your best in your science studies, and you'll enjoy nature all the more. Hey, let me close with prayer for my time. Lord, we thank you for a little session we've had here together, looking at the wonders of your sky. It's beyond us all. We can't imagine what you've made, but we thank you for the things you do reveal to us. Thank you for even those constellations of crosses in the sky. Thank you for loving us even more than the stars. They come and go, but through you we can have eternal life. Praise you for that. Pray for a good day on campus. Pray for a good weekend as well. Keep us on your path. In your name we pray. Amen. Thank you, guys.